This is a pyrolysis unit for biochar, and this is a complete continuous unit where they are using different type of biomass. This is the eucalyptus needles. This is the rice husk. So here is the feeder. So there is a sprue feeder. It goes here, and inside it burns. There is also a heater below, or a burner below, and here the flue gases will go up from the burner, and there is no smoke, you can see. And the biochar comes here and it gets collected here. This is 1 ton per day capacity unit, and also there is a facility behind to collect wood vinegar, bio oil, bioanthar, and other byproducts also. So this unit can also be made into the mobile pyrolysis unit, and individually people can adopt this kind of units for producing this biochar or even charcoal, or even they can reprocess it to make it activated carbon.
Good morning. I am Sampath. We have been working on pyrolysis from 2008. Mainly started with plastic to plastic pyrolysis, where we convert all kind of mixed plastics waste into oil. And now we're trying to take oil, methane gas, and then the carbon black. So we process the most difficult plastic that cannot be recycled. For example, fiber reinforcement plastic, carpet waste, resins, adhesive tapes, etc. And then my MLP films and the plastic found in municipal waste, plastic found in the legacy waste, etc. Then we have been setting a plant right from 5 tons per day to 20 tons per day. And from the day one, we always designed and executed a continuous plant. Then we moved to torrefication. For that, we tied up with IIT Guwahati in the year 2021, because the NTPC wanted to go for torrefication tenders, and we participated. And we are one of the only 4 approved vendors for NTPC for the country for doing torrefication. So NTPC has set up one plant in Varanasi to process 600 tons of municipal waste into torrefied coal, and that coal they are using it for their replacing it as a fossil fuel coal. And now they have already floated tender for Bhopal, Noida, Gorakhpur, and then Hubli, etc. So we have been applying for the tender. Then came the biochar opportunity, where we also, since we are pyrolysis in the field of pyrolysis, we thought we'll do the biochar also. So we started experimenting with the different feedstock. We started with sawdust, rice husk, cotton stalk, cotton cob. Corn cob we have not tried, but corn cob also we want to do that. And we have done the molasses waste. We have done the pine needles, which I think is very common in very dangerous stuff in Himachal Pradesh, Uttarakhand, Himachal Pradesh, because it catches fire, and then in the forest fire comes only because there's pine needles. So we have tried that also. So we have designed for the farmers, we have designed for the industries. So we have starting from 1 ton per day plant onwards to 200 tons per day plant. So when we started the biochar, so we wanted to try with the different materials. So we brought pine needles, which is fire hazard in the forest, especially in Uttarakhand and Himachal Pradesh and things. And that's why we tried that. We tried juliflora, we tried eucalyptus, and we tried rice husk, and sawdust is common thing. And then cotton stalk is the one which is, I think everybody is looking at. Okay. So we started using the cotton stalk and do this. The difference between the rice husk and cotton stalk is, rice husk can be mainly used for farmers. It reused in the field actually. So where we are talking about NPK value. And in the cotton stalk, being a good product, they want to have a high fixed carbon. So we thought we will do it at 700 degrees centigrade. So high temperature when we process the cotton stalk, it is giving you better fixed carbon. And then we also have some in the system. There's we keep the char for some time for a soaking time we'll give. And so basically we are with the residential time of the reactor in that the process whole thing get processed and come. The advantage of continuous process is there's no emission in the atmosphere. So whatever comes, it's the volatiles are recycled and then it's burned, and the chimney doesn't smoke. It's always clean, and so the carbon is quite good because there's no oxygen goes inside. There's no ash comes, so the ash content is very, very low, and we get a more pure. So we have also tried with bamboo. Biochar also we tried. We want to do one project with IIT Guwahati, and that project also we have done. So hopefully we'll do that also. So with our experience of 15 years in pyrolysis, we can handle any kind of material in a biochar.
Yeah, good sir. I think from Hyderabad already we have this progressive biochar society, and many people focused on biochar.
Right.
And you coming from the same place with this R&D as well as extension across India.
Yes.
I think the biochar movement or revolution that is happening already.
Yes.
And this will contribute a lot. I would also recommend to many people to visit this plant and understand, then adopt.
Yes.
So that this biofuel policies and biochar policies and everything are integrated, and even as a policy also we will also recommend that this kind of initiatives.
I am Dr. Azaz Ahmed. I am working as a R&D research and development head at Pyrogreen Energy Private Limited. So we are at our Patancheru R&D facility. So here we are making, for past 15-20 years, we have been making machines for reactors for plastic to fuel. And now we started making machines for biochar also from biomass. So this biochar has many applications, for starting from soil amendment to the reducing agent in steel industry, and also we are testing mixing a small amount of biochar in concrete, and we are going to test its strength. Okay. Yeah. So this is 150 by 150 by 150. This is used for testing that concrete for compression strength and the other properties. So if this, we also make, we are making some 3 formulations along with control without any biochar. Then we compare the strength of all these when we take it out. And also we test using, there is software called Design Expert, that also we use, and we get some 10-12 formulations. We also test that and we take it out one best one from that. So in our, we also have laboratory in Medipatnam. There we continuously test our product, oil and biochar, and propose how to increase the quality of that oil and biochar. So it's our continuous process, not that simply the making machines and leaving. So continuously we develop our machines and products.
Books, sir. We can introduce what is this from?
Yeah, this is our experimental reactor, small, same pyrolyzer, experimental. So if you, before doing anything, we do in a small quantity. Working in a larger quantity is not there. So we fix the parameters. This one, and also in laboratory we have one very small also. There also we test, here also we test, then it goes to the bigger. Parameters we set. Temperature, residence time, and how much moisture content we have to leave, how much dryness we require, all these parameters. Then we test after that. After that only we send samples to the third party laboratory.
We have seen a very good plant today, Biochar, and there's a need for equipment like this to be made available because Contiki type or other equipment have released a lot of hot gases. In this, the recovery is full. From biomass, we get biochar, bio-oil, and syngas. Many value-added products can be made. The main challenge now is effective cost. And I also suggest to Mr. Sampath to make it portable because making it fixed position, biochar is problematic. So there are portable design. This design can easily put in a container. You can make it portable. A portable design will really help, and that is popular in US also. In India, has been the cost is a very important factor. We will work with the government for subsidy. There should be subsidy for the modern plants available.